probably find on Twitter. That's a 0, not an O. And I'm also a software developer. I'm really weird. Please hackle along constructively.
I was wondering if we could get a quick show of hands before we get going. How many people here would consider themselves a developer? Okay, that's most people. Okay. What else? Maybe shout out something else? Testers. We've got some testers. How many testers? Great. Okay. Yeah. So this just helps us know how to test that.
So it used to be a thing that if you were testing your code in production, it was a sign of a lapse or non-existent QA or QC teams. But the times have changed, and it's increasingly being seen that testing in production is in fact the only way to get meaningful feedback from the code and features that you're deploying. So we're going to be talking about how we incorporate this into our software development and Unruly.
So we're going to be talking about various different types of testing. We're developers, so often when we're talking about testing, we're thinking about kind of automated tests, test-driven development, which testers often tell us we should be talking about checking instead. I kind of agree, although it's hard to get out of the habit of calling things tests all the time, so I apologise if I use the wrong terms. So we're going to be talking about actually all different types of tests, from the kind of things that QA team people do traditionally through to our automated tests, and how we apply all of those things to production. As we said, we both work at Unruly. We're kind of a medium-sized company, about 200 people globally. We have a tech team of around 30-35, all based in London. We've got 4 dev teams, all quite small. And we're all extreme programming teams, so we're regularly doing things like pair programming, test-driven development, and we're continually trying to make our practices more extreme and find ways of learning more quickly, which is kind of how this stuff came about.
So in addition to pursuing in-house and executing, we follow what we would call continuous integration, continuous delivery guidelines quite thoroughly. So here is a typical day for us. Each blue vertical line is a deployment of one of our systems, and we like to keep this up so we can see whether any regressions have been introduced. We like to say it's discrete delivery because there are still gaps in here, so we're not continuously deploying here. That big gap in here.
Yeah, it's not uncommon for a single team to be deploying kind of 10 times a day to production. I mentioned we do pair programming. We're actually increasingly doing log programming, having more than just 2 people working on a thing at a time, and we're doing a talk on that later if you're interested. It actually helps. When you're working collaboratively, it very much helps apply the kind of practices we're going to talk about today. Another interesting aspect of how we work is that we're not just a development team. We've got ourselves kind of product development team. We're responsible for the full life cycle, from helping the business come up with new valuable things to add to the product or things to experiment with, through to building them, all the way through to keeping our systems running in production. And an aspect of this is that if something goes wrong in production, it's the developers who are going to get paged or woken up in the middle of the night. So having that responsibility means we can also have the freedom to kind of release things as regularly as we like, apply all these things directly in production, because we're able to kind of make the trade-off between how risky things are, how valuable things are, because we have the responsibility of looking after them.
So the shape of our talk today is going to be comprised of this. So we have 3 roughly equal things that we want to talk about. So firstly is how we do testing in production. So the how of what we do and how we think it helps us deliver better, more valuable software. The second part is how we do the lower level stuff. So integrating monitoring into our TDD, our actual software code writing lifecycle. And then finally, we're going to talk about deliberate ways that once we've got these continuous delivery and monitoring nets set up, how we are deliberately sabotaging our own systems to gain the maximum amount of learnings that we can to form our decisions. So when I say testing in production, it's something that we do quite a lot of, especially for delivering features. So we have 2 environments, development and production, and we have nothing in between. So there's no UAT, no capacity testing or load testing environments. It's once the code has left your workstation, it's up in it's on the live servers and it's receiving live traffic. And because of the way we work, we're very big fans of what Stephen described as trunk-based development, so working in very small commits, pushing those commits up to production. We're continually getting feedback from our systems, and so we know that when we deploy a change, that it is going to work, rather than waiting until the entire thing is fixed, or the entire thing is done, and figuring out where a regression is introduced if it has one. And one of our main things that we have to do for our internal customers is engage with them. So one of the XP things is having a customer in the team, and we try and work very closely with our customers where possible. And the way that we use our testing and production to do this is to use our feature toggles. So rather than by eschewing the use of a UAT environment, we're enabling our internal users to use our application much in the same way that we would. So when we're developing features for them, rather than us pushing it out in a big bang, they are seeing the feature as it evolves. So not only can they interact with it and tell us whether we're going down the right thing, but it means that if we're going down the wrong path, or the spec that we think that we should be working on is in fact not the spec that they wanted, they can highlight it very quickly, and it means that we can eliminate any wasteful development, which is a real win for us. So these feature toggles can take, so in the form of our ad units, it might be an if statement if we want to restrict it to a particular ad campaign, or a particular country, or a particular audience profile of our users. Or for our internal applications, it might just be a role, so it might be a particular subsection of our users who want to be able to see this feature. And then when they're happy with it, it will be released, pushed out to a wide audience. And so this means that we can get sign-off quite quickly, because we don't have to worry about setting up things for our users. They're just using it already, and because they're so tightly involved, once they're happy with it, we can just sign it off. So nearly no pointers back and forth. We've also recently started doing a lot of exploratory testing. So in particular for our ad operations team, where they're setting up units for our clients for their ad campaigns, we want to find out all of the edge cases on the metaphorical map, so stake out where things start going wrong. So if I upload too big a file to the banner on the top of the ad, what happens? How does it behave? Does it rescale it correctly? And we do this by actually pairing with the other departments. So we'll go up to them and we'll sit, because they have the domain expertise for how they're actually going to be using it, and we have the technical, and we can figure out how we're actually going to be delivering these things that we want, and figuring out if there are bugs.
People often ask if we're doing things like exploratory testing, testing in production, like intentionally trying to break things in production, or using things that may not be finished in production. How do we handle the mess that might be generated by them? If we've got users generating bad data, or if we've broken something, it generates invalid data, how do we deal with that? We basically take the same approach as with the feature toggles, but apply it to the data. So there's a number of slightly different techniques. With our ad units, we might have a flag that turns off the data collection problem, so you can test all of the other aspects of them without having the side effects generated in our reporting system. In more traditional web applications, in the database, we might have a flag against different types of data that indicate that they're test data, and thus shouldn't be included in different types of reports and so on. Obviously that only gets you so far, but it does let you do a lot of different types of testing directly in the production system without worrying about what happens to it. And it means you can quite easily clean it up again afterwards. And again, sometimes we tie this to a user role, various ways of toggling them on and off. I've got a blog post about this, so I'll give you the link at the end.
And finally, another thing it's useful for is we try and operate in a very lean way, especially when developing new features or new products entirely. So the code, it doesn't matter how good the code we're writing is, as long as we need to get it into production, find out whether it's generating revenue, generating actual tangible value for the business. Because if it's not, then that just was entirely wasted code. So as part of this, Benji has recently started working on a new unit, and as part of this, even the smallest walking skeleton changes, the smallest things get pushed out and pushed out, and these are all tested by our BD team, people who will be going out and selling these things to our clients, and we are enabling them to deliver these incremental features and talk to our clients about them we work so closely with them.
It's much easier to do things like A/B testing in production. If we get it out of production, we can just easily turn that on, say 1% of our users and get lots of feedback, or does that affect different things that we might be measuring? Have we made a regression? So you get that data much more easily in production. And we can also apply a lot of the kind of automated acceptance tests that we normally do as part of our development cycle to our production environment. And that's what we want to talk about the rest of the talk, being developers at heart. So I want to try and persuade you that monitoring checks in production and the kind of tester and development checks that we'd normally be doing are pretty much the same thing. And we can think of them in the same way, apply the same tools to them, and we get the same kind of information back from them that helps us improve our development as well. What are unit tests or integration tests, acceptance tests? They assert some aspects of behaviour of our system, and they can either pass or fail. And so if we regress something that it starts failing, we can go and fix it. So it's just a set of assertions about the state of our behaviour of our system. What is a monitoring check in production? I'd argue it's basically the same thing. So we use Nagios for running monitoring checks in production. Not a particularly great tool, don't know if I'd recommend it, but even with Nagios you can do things in this way. Nagios will execute some code, it can either pass, fail, or be unknown, just like a test, automated test. Thus you can treat it in pretty much the same way, and as I hope you'll see later on, we can often even reuse the same test code in production. We like to make sure that our checks in production or our tests in production are the same as how we write tests for our code. We want to be interested in, are we checking value rather than kind of implementation details? So we're more interested in how much money are we making, has that suddenly dropped off? Is anyone able to use this application? Are they able to perform this function in production? And we're less interested in, is this server up? Because hopefully our systems can cope with that, and if the server goes down and it's important, then it's probably degrading something that the business actually cares about. So we try and invite our focus on monitoring the things that actually matter, and the other things fall out. I mentioned earlier that developers are on call when things break, but what we've actually found is where we've been successful at writing monitoring checks that check things the business care about, they've actually asked to be put on to be SMS by our production monitoring system when things go wrong. So we've got some people from our media team who get alerts when big publishers stop receiving money. We have someone offshore, obviously, who I've forgotten. But yeah, other teams have started being interested in knowing when these things break at the same time that we do, and we thought that was quite interesting. So I mentioned we can run the same code often for our tests. We use, for our app formats, we use Selenium WebDriver for kind of acceptance tests to check that certain bits of behaviour are working, and we run all of those tests every time we deploy something up to production and check that we haven't regressed anything in the code. But what we're actually able to do is take those same tests and run them against the production instance, because it's just a web app, it's just a different URL in production. We have, when we're deploying stuff, our test runner runs the tests. In production, Nagios can run the tests. So just execute a test case, it either passes or fails. If it fails, our monitoring system tells us. There's really no difference there. We won't get into the details of how this works now, but suffice to say we can deploy those tests to production and get our monitoring system to execute them for us. So why would you do this? Why not just rely on the fact that you're running all those tests when you deploy stuff, and if we don't have it deployed anything different, then nothing's going to break, right? No. Loads and loads of things can change in production that break the production system without you actually having deployed anything different. The big one is time. Has anyone ever run into a leap second bug or leap year bug or anything like that? No? A few nods. Don't believe you, I've run into them all the time. At least twice a year. Okay, we don't have leap years every year, but leap seconds. Yeah, there's all sorts of things like that that cause problems. So we know when we deploy stuff that it works because we run our tests, but we don't know if it's been working on the time in between unless we're monitoring that. Similarly, we as developers, we like to think about systems as kind of data pure functional blobs. Data goes in, data goes out, and it's always going to behave the same. We release a new version, it behaves slightly differently. But we have these kind of nasty blobs of data attached to things with loads of state or databases that's changing all the time. We have users who are injecting different data into that state, and that state often changes the behaviour of the system, unless you have a completely stateless system. And so that's another reason why a system might stop working at some point in the future.
We also run to third parties, which is while we're quite strict about deploying new changes, not deploying broken things to production, we can't guarantee that the people that we're integrating or consuming will do exactly the same. So that's another thing that can break without warning. So even though it's nice to be advised of any potentially incoming change, there's no hard and fast guarantees that code you're expecting to be the same is not going to change out of time use. So anything from API changes to application code just entirely disappearing. There's also traffic. So unfortunately, traffic, because we distribute our ads globally, traffic is neither constant nor predictable really. You have peaks and troughs, you have spikes, and you have ebbs as well. So while your system may be able to cope at what is the average load across the world, can it suddenly cope with 10 times that if either a problem is introduced or certainly on board a large publisher who is delivering a lot more traffic. So this is something that could break the system as well. And also there's the layer below the application, which is that of the infrastructure. So we use AWS for our hosting provider, and they sometimes have a habit of turning off your EC2 instances when you don't like them, when you don't want them to. So even though that means that we do architect our systems for failure, it's just something that we can't count on to not happen, and it does cause software to behave in unpredictable ways if you don't plan for it. What this means is that all in all, even if your system is perfectly pure, formally verified software, it's still a ticking time bomb, and there's a lot of things that can go wrong that are completely out of your control.
And we're not only interested in can your system cope with more traffic, or can your system cope with whatever thing event is coming up, but is it still meeting the same acceptance criteria in production now than it was when you released it?
So we started to try and do this thing that we call monitoring-driven development, and like every thing modern software development, we need to have a hashtag, so we call it MDD. So monitoring-driven development for us is where we incorporate, as Benji says, not just running the acceptance tests for our code in production, but treating writing tests the same way we treat writing checks for our production. And Benji's going to talk a bit about that now.
So how many of you do test-driven development? Most people, that's good. So test-driven development, you start by writing a failing test, then you write a small bit of code to make it pass, then you do some refactoring, maybe make it pass in a more sensible way, clean it up, go back and write the next failing test. And you go around like this, you get feedback about whether your code works, and you get feedback about the design of your code, because if it's hard to write the next failing test because you haven't done enough refactoring. So we gave a talk a couple of years ago, and we were talking about how, because we deploy so frequently, we find that the feedback from deployment and the information we get from production fits into this feedback cycle. So at some point we've gone around a few times, we've got a minimal set of changes we could deploy to production, and we go and deploy it. We wait for the deploy to finish, we check everything's still working fine, our monitoring hasn't alerted us to any problems, and if that's all fine, we go ahead and write the next failing test and continue our development cycle like that. We've actually started to come to see it a bit more like this, where we've got our little test-driven development loop that's very, very short, and the minute's a bit optimistic, but we're talking in an order of minutes to write some failing test, make it pass, and iterate on that change. But where we actually like to start the process is writing a failing monitoring check in production. So we'll write a check, deploy it into our production monitoring environment, asserting that our application has a bit of behaviour in production. That'll go red on our monitoring dashboard, and then we'll then start doing our normal TDD loop to implement that functionality. And at some point, we'll deploy a change that will make that check pass. And at that point, we can go back and do it again. And just like with the refactor step in test-driven development, there are smells we get from our checks that help us improve the design, and it's important to kind of improve the higher level design of our systems in the same way you'd be improving the low level design when you're writing tests in the test-driven development sense. What kind of smells are they? Well, in the same way when you're writing tests, if it's hard to write the next test, maybe you're doing something wrong. If it's hard to monitor what you want to monitor, maybe you're doing something wrong. If you find yourself, you want to check some aspect of the behaviour of the application, and you need to go poke into the database of that application, look at its private state, then maybe either your application has too many responsibilities, or it needs to be publishing that information because it's interesting to people. So that can be a smell that indicates you want to improve your design. If you find yourself copy-pasting all your checks, then that's probably a sign you need to improve design somewhere, whether it's in your monitoring framework or whether it's in your applications, because the same things get done all over the place. Similarly, when we have automated tests, non-deterministic tests are a killer for us being able to rely on them. If they keep failing regularly, people will start ignoring them. So it's important to be to quarantine or delete tests that are unreliable and they don't give us useful feedback. And the same applies to our monitoring checks in production. If we're being paged all the time by useless things, then no one's going to pay attention to the important things. An interesting aside on this, we had a fun example of trying to apply this where the check itself altered the behaviour of the system. We had a complaint from our Singapore office that some pages in the application were very slow during the time we were all asleep and they were awake. So we applied our normal process. We deployed a check to production that asserted that the response times of these pages were within a certain threshold. And it was green. We expected it to go red during these times when they were having problems, and it actually didn't. And then they reported the problem had gone away. And the problem, so what turned out to be the case was that these checks, by hitting those pages, were keeping the relevant caches warm, and nothing was slow at all. It's useful to be aware when you're doing this kind of thing that what you're monitoring also has an effect on the production system. Like in some cases, you could even overload your production system by sending it more requests than you expect.
So now that we've been writing these tests and we're running them in production, and because of the way we write our code, we can react quickly to deficiencies or things that we break. How can we best capitalize on this? So in addition to our system passively going wrong, as we talked about it, and us being able to fix them, we can try and proactively make our system go wrong by doing deliberate failure injection. So in his Making manifesto, Kent Beck recently said that the production is the only source of truth, and in addition to this, anything else is a simulation. So we sort of touched on this earlier on in the talk, where we only have our production environment and all of our data comes from there. So what we've been doing with our failure injection is trying to deliberately sabotage our own software in the worst case that we can imagine, so we can be relatively sure that in these worst case scenarios we can at least at worst degrade gracefully, or even just handle the problem and not hopefully go away. So we have two main systems that are really in the back end. One of them is very throughput concerned, so they ingest quite a lot of data. They have MapReduce jobs, and their main concern is that eventually they will reach a point where their current system is no longer able to handle it, and this is what happens. So this mass aggregation was originally done in database before they moved to MapReduce. But what they did was they manually multiplied the traffic that they were getting during controlled load tests showing off the cells, and this gave them a moving window of 100 times in the future. So if our current input is 100 times what it currently is, can we handle it? And they went for a good period of time, this is fine. And then one day it stopped, and they just weren't able to handle it. And rather than this actually happening in production and everything catastrophically breaking, this gave them about 2.5–3 month window to essentially re-architect the entire system. And if we hadn't been deliberately injecting this data and trying to push the limits, then it would have happened and a lot of stuff would have broken, and there would be a lot of manual development work, both mediating and firefighting without doing the proper re-architecting work. In a similar way, we also have a team that's very concerned by latency. So the ad ecosystem on the internet, so things that show through the ads, essentially works like this. You have a user who sees an ad, and what this ad does is it fires off requests to something that monitors performance of these ads. These ads inform decisions for bidding systems that try and say, like, oh, actually, I do want to show an ad to this user, or I've shown this ad to this user before, don't bother showing it to them. And this informs decisions in auctions run by an ad exchange, which displays the ads. And because this is entirely cyclic, latency introduced at any point during this will slow everything down. And not just slow it down, but it will start dominoing and cascading. So it's very important for us to be able to figure out where, if there's a massive amount of latency, what's going to break first. And in a similar way, our ad units, we use our actual on-production ad units as the engine of our load tests to, again, multiply out the traffic and figure out what parts of this system break. So this isn't just going into these the stats and going into memory and being processed. This is being written to databases for payments. This is being written to other databases for reporting. And all of these have different characteristics. All of them have different rates at which they can ingest data. And so by, again, trying to keep this window, we know which system will fail first, and we can start with this breathing room, start architecting for, well, maybe a relational database isn't the correct way that we should be doing this. Maybe we should move to something that's more columnar, that's better suited for large-scale ad queries. And not only that, but because of the way we architect our system now, we can also figure out where the bottlenecks in the pipeline itself are, rather than just at the endpoint, and we can scale accordingly. So if we need more nodes at the edge, or if we need better ways of sequencing our data.
People often ask at this point, isn't this terribly risky, intentionally throwing loads more data, intentionally trying to break our production systems in different ways? But I'd argue it's again for a few reasons. One, we kind of design things so that they fail in predictable ways. We use things like circuit breaker pattern, which I think Netflix talked a lot about, where you have like a circuit breaker in your system that cuts off traffic if there's too much. The kind of production load generation that Alex talked about, those automatically stop if they detect that any part of the system has got overloaded. But even if that doesn't kick in, I still think it's better for us to be intentionally trying to break our system at a time of our choosing, while we're all at the office able to respond to it, than having it happen at like midnight or 2 in the morning when we've had a large ad campaign go live, or something's gone on with one of our publishers and that's out of our control, and suddenly we're trying to deal with it while we're half asleep. So if we don't break our system, someone else is going to do it, so let's do it when other time we control.
So I talked a bit a couple of minutes ago about one of our products, which is the ad auction. So we control an ad exchange, which for our publishers, the ad unit sends off requests to the exchange. This ad impression is auctioned off, and they say, actually, I want to show an ad to this user. Maybe they're the right demographic, or maybe they only want to target an ad towards an iPhone user or something like that. And the winning bidder gets to show their ad. And so, since we're not the only people participating in this auction, we also have a lot of third parties participating in this auction, and we want to make sure that because we have requirements that our publishers impose on us. We don't want to, for example, we don't want to break their site by loading ads that contain malware. We don't want to load ads that just suddenly take over the entire site or that slow down the load at all. So we like to try and enforce these characteristics on our third parties. And a mantra that we like to try and go by is, where possible, we want to shake the production tree and see what falls out. So for us, we like to introduce what we call monkeys in the production tree. And what these are bidders that during the load test we introduce to the global pool of people participating in the auction, and their goal is to deliberately sabotage the auction or to violate the contracts that we have imposed on our third parties. So we do integrate with these third parties a lot, and it's important that the auction can handle these failures because this is the neck through which all of our hand traffic goes. And if a single badly behaving client is sabotaging the auction, then that will bring nearly everything down, so it's absolutely unacceptable. So one of the examples is something that gives back bad data. We conform to a protocol called OpenRTB. It's an industry standard for offering up ad auctions, and we want to make sure that our third parties are compliant with the spec. So in particular, we send something that sends back nonsense data or sends back malformed data, not just because we want to ignore it, but if whatever's deserializing the responses is using exceptions in such a way that it's actually degrading performance for flow control, that's something we want to fix and be aware of. In a similar way, timing is also very important. There's, again, an industry standard of around 100 milliseconds. Anything more than that is unacceptable because then a user can perceive that a page is taking a long time to load. And we actually uncovered quite an interesting bug with this because of the HTTP client we were using to run our auctions. So we send off requests to the bidders and they come back. And when they were timing out, they weren't disposing of the connections correctly. And what this meant was that when we were running these load tests during production in office hours, we were observing that it wasn't being garbage collected correctly, and there was a massive memory bloat during this period that wasn't taken off. So we dived in without profiling because we knew what was going on, so we could simulate the same thing locally. And we diagnosed it, and we replaced the HTTP client, and everything was fine. And the way we like to think of this is in the test case of checks versus properties. So what Benji was describing, so running our checks in production, running our Agile probes, they're a lot like the sensor checks. So they're asserting a particular fact about our production system, whereas these failure injections are much more about asserting a property of the system as a whole. So our system must be resilient to malfunctioning clients, or our system mustn't fall above a certain latency threshold. And these are the two halves of how we think about monitoring development and how we do it in Unruly.
So, wrapping up, we've told you about how we don't have a test environment, don't have any UAT testing environment or load testing environment. We do all of this stuff in production. I'd argued that monitoring in production, either whether it's monitoring examples of behaviour or properties, is pretty much the same as the kind of automated tests that we write as part of our normal development cycle, and we can apply the same approaches to it, learn the same things from it, and even sometimes reuse literally the same code to run against our production systems.
And yeah, this is what we call monitoring-driven development. So we are using not just our tests to inform the design and the creation of our code, but our monitoring, which to us is exactly the same thing. And additionally, we want to capitalise on our system being broken because it will break. It's just going to happen, accept it. And so the best thing we can do is try and break it ourselves and at least gain learnings from that on our own terms.
Thank you very much for listening.